welcome to my lab. You guys are just in time for my next big adventure. I'm gonna sell lemonade. I even have my own special formula. Doesn't it look delicious? It's very tasty. My only problem is I can't keep it cold for very long because my ice keeps melting. So I looked online for some tips and I found a really good tip. It says, for longer lasting ice, decrease the surface area to volume ratio. Except, I'm not sure I understand what that means. Because I understand what area is, but how can an ice cube have area? It's not even flat. So what's surface area? I don't know. Do you? Can you help?
Let's open up the cube to separate its surface and volume. The area of each side of the cube is A times A. There are 6 sides in a cube. Thus, the total surface area becomes 6 times A times A. The total volume of the cube is A times A times A.
Okay, so now I think I understand a little bit better what he's talking about. The surface area is just where you take the area of all the different surfaces of an object and you add them all together, and that's the total surface area for the whole object. Makes sense. So now if we go back to my tip, which said for longer lasting ice, decrease the surface area to volume ratio, I'm still not quite sure what that means, but it sounds like I'm supposed to decrease the surface area, which if I wanted to decrease the surface area, I guess I would have to make the area smaller, which would happen if I made the object smaller, right? For instance, if I took this cube, which is 3 times 3, which is 9, times 6 sides, which is 54, and I compare it to a cube that's 1 block shorter, so that's 2 times 2, which is 4, times 6 sides, which is 24. That's a lot less surface area for this cube than for this cube. So maybe what I need to do is just make my ice cube smaller. Maybe that'll help. Well, I'm a scientist, so I like to test things out first. So what I have is one ice cube here, and one ice cube that's about half the size of the first one. And I'm going to see if decreasing the surface area of that second ice cube helps me to have the ice last longer than I expected. This may take a little while. Well, that didn't work. This second ice cube definitely melted faster than the bigger one. So if the one with the smaller surface area melted faster, then I must not have understood that tip very well. Decrease the surface area to volume. Wait! Volume! When I made this one smaller, I also changed the volume. Maybe that has something to do with it.
As seen before, the surface area is 6 times A times A, and the volume is A times A times A. After dividing, we see the surface to volume ratio is 6 by A.
So I can see from that equation I was totally on the wrong track before. That equation has length on the bottom, which means that the smaller I make my ice cube, the larger the surface area to volume ratio. It's an inverse relationship. So if I want to make my ice last as long as possible, I want to decrease the surface area to volume ratio. That means I have to make the length, the size of my object, as big as possible. So I think I have the perfect ice cube. Well, almost perfect.